Okay, here is another card presentation by Jason Ladanye that I was hoping to talk about for just a few minutes. So I'll add a link in the description below to his original performance here and encourage you to watch it, as well as a link to a video in which I explain this amazing mathematical card effect in great detail and show how this effect will actually always work for you. And I'll do it by using some special mathematical notation invented by Norman Gilbreth. Okay, so let me just play a portion of Jason's video here. So he's divided the deck exactly in half, 2 packets of 26 cards. Now he has the spectator freely cut off any number of cards from one of those halves, okay? And to set it aside, he takes the other pile of 26 and freely mixes it. From that pile of 26, he's going to have the spectator randomly choose a card. Okay, this is a free choice. So it looks like the spectator is going to randomly choose the 3 of diamonds. He sets that on the table and then sets the remainder of that packet of 26 on top. So the spectator's card is at the bottom of that pile of 26. And then he sets that pile of 26 on top of the uncut cards. At this point, he's going to perform what's called a Klondike shuffle. And a Klondike shuffle is where you take the top and bottom cards off as one. Okay? So you just draw them off as pairs, just like that. And he jokes that this is the most exciting part of the presentation, which of course is a joke because it's a bit tedious that you have to do it for the whole deck. Now in the example I'll show you, instead of using 2 piles of 26, we'll use 2 piles of 6 cards. Okay, so you can more readily see what's going on. Okay, so he Klondike shuffled that portion of the deck. Now he's just showing for the first time how many cards the spectator freely cut. And I believe it's 12 cards. And that was a free cut. Okay, that was really random. And now he's going to count to the 12th card. So the 12th card down ends up being the spectator's card. The number of cards cut exactly takes you to the position of the spectator's freely chosen card. Absolutely amazing. Now, in my opinion, this is one of the greatest and most impressive mathematical card tricks ever invented. It really is that good. Here I have 2 piles of 6 cards each instead of 26 in each. Okay, that will help us see what's going on. So what we do first is you just have the spectator point to either pile. It is a free choice. So let's say they point to this one. You have them cut any number of cards whatsoever. That's a free choice there. Any number of cards from one of the piles. Now you turn to the other pile that hasn't been touched yet. And that pile can be freely mixed by the spectator however they like, riffle shuffled or whatever. Here it's just 6 cards, so it's not too hard to mix it. And then you have the spectator randomly choose a card, any card in here. So maybe they choose that one. So Queen of Diamonds. Now if you remember, he set that at the bottom. These go on top. But I thought we would have it face up so that we can see what's going on a little bit better. Okay? And then if you remember, this goes on top of the uncut cards, just like that. Okay, and then from there you just do the Klondike shuffle. So this is where you take the top and bottom off as one, set those down like that, and spectator's card's going to be coming up here soon. There it is. Okay, and then what happened in the finale there is the number of randomly chosen cut cards here, which is 3, agreed exactly with the position of the spectator's card from the top. And we can see that to be the case here. 1, 2, 3 will take you right to the spectator's card. Okay, and then in the video that I'm linking down below, I actually give you a full mathematical proof as to why this works, and this is Norman Gilbreth's notation in action. Okay, so if you want to take a look at that, I'll explain exactly what all of this means, and it proves that this routine is guaranteed to work no matter how many cards are cut from that pile of 26 cards. Doesn't matter how many are cut, that number of cards will in fact locate where the spectator's card will be after the steps shown here in the video and the Klondike Shuffle has been performed. So take a look at that video if you're interested in understanding the mathematics behind it, and perhaps more importantly, to learn the basics of Gilbreth's notation, because once you have that under your belt, you can actually design countless card effects. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.